麦克一样，没拿好。
对了。
Hi, my name is NIANSON. Hi, my name is GUAN. Hi, I'm LEONG.
A diode is made from a small piece of semiconductor material in which half is doped as P region and half is doped as an N region, with a PN junction and depletion region in between. We normally use silicon as the material with a PN junction connected to two electric terminals. The P region is called the anode and connected to the conductive terminal, and the N region is called the cathode and is connected to the second conductive terminal.
The most common function of a diode is to allow an electric current to pass in one direction, which is called forward bias, while blocking current in the opposite direction, which is called reverse bias. The external voltage required to move the electrons through the electric field is called barrier potential. Typical values of barrier potential at 25 Celsius is 0.7 volts for silicon and 0.3 volts for germanium. Thank you.
The positive terminal of the bias battery is connected to the P-type material and the negative terminal of the battery is connected to the N-type material. The positive potential repels holes towards the junction where they neutralize some of the negative ions. At the same time, the negative potential repels electrons towards the junction where they neutralize some of the positive ions. Since ions on both sides of the barrier are being neutralized, the width of the barrier decreases. Thus, the effect of the battery voltage in forward bias direction is to reduce the barrier potential across the junction and to allow majority carriers to cross the junction. Current flow in the forward bias PN junction is relatively simple.
An electron leaves the negative terminal of the battery and moves to the terminal of N-type material. It enters the N-type material where it is the majority carrier and moves to the edge of the junction barrier. Because of forward bias, the barrier offers less oxygen to the electron and it will pass through the depletion region into the P-type material. The electron loses energy in overcoming the opposition of the junction barrier and upon entering the P-type material, combined with a hole. The hole was produced when an electron was extracted from the P-type material by the positive potential of the battery. The created hole moves through the P-type material towards the junction where it combines with an electron. Therefore, when a PN junction is forward biased, there will be current flow because of majority carriers crossing.
To reverse bias a junction diode, the negative battery terminal is connected to the P-type material and the positive battery terminal to the N-type material. The negative potential attracts the holes away from the edge of the junction barrier on the P side, while the positive potential attracts the electrons away from the edge of the barrier on the N side. This action increases the barrier width because there are more negative ions on the P side of the junction and more positive ions on the N side of the junction. The width of barriers has increased. This increase in the number of ions prevents ion flow across the junction. Therefore, when a PN junction is reverse biased, there will be no current flow because the majority carriers carry a very small amount of current crossing the junction. However, at normal operating temperatures, these small currents may be neglected.